All right, welcome everyone. If you're an AI architect, you're in exactly the right place. Today, we're going to get our hands dirty and really dissect the core blueprints of modern AI. We're talking neural network architectures. We're going to explore those fundamental designs, the ones that power the incredible systems you're building every single day.
So, here's our game plan. We'll start with why neural networks are the engine of this whole thing. Then, we'll break down the anatomy of a network. After that, we'll get into the big players: feed-forward, recurrent, and convolutional networks. And to wrap it all up, we'll see how this stuff works in the real world.
Okay, let's dive right in. Section 1, Neural Networks, the engine. We're talking about the absolute core of modern deep learning.
So what even is a neural network at its core? Well, think of it as a collection of really smart algorithms that try to mimic the human brain. Its whole job is to look at a mountain of data and find the patterns, to make sense of all the noise. And it learns. It does this by constantly tweaking its internal knobs, we call them weights, to get better and better at its task, minimizing mistakes with every single pass.
And this whole idea of layers is what gets us to deep learning. It's actually pretty simple. Once you have a network with more than just an input and an output layer, once you add at least one of those hidden layers in the middle, boom, you're officially in deep learning territory. And the more layers you add, the deeper it gets. This depth is so crucial because it lets the network learn things in stages, It starts by seeing simple stuff like edges and textures, and then combines that knowledge in later layers to understand much more complex things, like a face or a car.
All right, so now that we know what they are, let's pop the hood and see how they're built. We're moving on to the anatomy of a network, deconstructing those fundamental layers.
Look, no matter how ridiculously complex these architectures get, and believe me, they can get complex, it all boils down to this same basic blueprint. Every single one has these three parts. You've got the input layer, which is basically the front door for your data. Then you have the hidden layers. This is where all the magic happens. And finally, the output layer, which gives you the final answer. That's it. That's the fundamental path for data in pretty much any neural net you'll ever build.
And it is so important to get that these layers have very different jobs. The input layer, it's just a pass-through. It takes the data and hands it off. No thinking involved. The output layer gives you the final prediction. But the hidden layers, that's the brain of the operation. This is where all the heavy lifting, all the computation, and the real learning actually happens. It's in there that the network is constantly transforming the data using all those weights and activation functions to pick out the complex patterns we need it to find.
Okay, time to get into the specific types of architecture. Let's talk about feed-forward and recurrent networks, and really focus on how the way data flows through them completely changes what they're good at.
And here's the fundamental split between these two. On one hand, you have feed-forward networks. Think of this as a one-way street. Data goes in the input, flows through the hidden layers, and comes out the output. That's it, no looking back. This straightforward approach is perfect for static problems, like classifying an image or predicting a number. But then, you have recurrent networks. These guys have a trick up their sleeve, a feedback loop. This loop lets information persist, kind of like a short-term memory. And that memory is an absolute game changer when you're dealing with sequential data, where what happened a second ago deeply impacts what's happening now.
All right, next up is a real specialist in the field. The Convolutional Neural Network, or CNN. These are the networks you turn to when you're working with a very specific kind of data, grid-like data. And when we say grid-like data, let's be real, we're mostly talking about images. I mean, what is an image but a grid of pixels, right? The secret sauce of a CNN is its special convolutional layers. Now, these don't just look at one pixel at a time. Instead, they use these little filters, almost like a magnifying glass, to scan across the image and look for patterns. First, it finds simple things like edges and corners, then it combines those to find textures, and then it combines those to find whole objects. It's this ability to build up understanding from simple to complex, to see how things are arranged in space, that makes them absolute kings of computer vision.
And this whole process really gets to the heart of why deep learning is so powerful. It's this idea of autonomous feature extraction. Think about it. The CNN learns on its own what an edge looks like. The RNN learns on its own what the rules of grammar are. For you as an architect, this is a massive deal. It means you don't have to spend months trying to manually code what features matter. You just feed the network the raw data, and it figures out what's important all by itself. That is an unbelievably powerful capability.
Okay, enough theory. Let's get practical. In our final section, we're going to see these architectures in action. How do you actually match the right network to the right task? Let's connect these designs to the kind of problems you're probably trying to solve right now.
So where do you use a good old feed-forward network?
Well, think about any problem where the input is a standalone package. There's no before or after to worry about. Like, is this email spam or is it legit? That's a simple yes/no. Can we recognize this handwritten number? That one-way data flow is just perfect for these clear-cut classification jobs.
Now, for recurrent networks, it's all about that memory. It's for tasks where sequence and context are everything. You can't translate the last word of a sentence without knowing the first words, right? You can't understand what someone's saying if you only hear one sound at a time. And you definitely can't generate a coherent paragraph if you don't remember what you just wrote. For anything involving language, speech, or time, that internal memory loop isn't just nice to have, it's absolutely essential.
And CNNs? Well, they completely own the visual world. Anytime you're dealing with patterns and images, this is your go-to. I'm talking about automatically tagging your friends in photos, or the object detection systems that allow self-driving cars to see the world. And let's not forget the really critical applications, like in medical imaging. A well-trained CNN can look at an MRI or a CT scan and spot tumors or other problems with a level of precision that can be life-saving. It's truly incredible stuff. So, let's put it all together in a quick cheat sheet. If you've got static, tabular data, think spreadsheets. A feed-forward network is your bread and butter. Got data that happens over time, like language or stock prices, you need the memory of a recurrent network. And if you're looking at pictures, videos, or anything grid-like, the pattern-finding power of a convolutional network is, without a doubt, the way to go.
And this really brings us to the most important takeaway of all. As an AI architect, your biggest job isn't just memorizing what each network does, it's about being able to look at a problem and frame it correctly. If you can deeply, truly understand the nature of the problem you're trying to solve, the problem itself will practically scream which architecture you should be using. So I want to leave you with a final question to chew on. We're seeing all these crazy hybrid models emerge now, right? Things like transformers that borrow ideas from both recurrent and convolutional networks. So the question for you, as the people designing the future, is this. What are the truly fundamental principles that will matter most? Is it memory? Is it spatial awareness? Or is it something totally new that we haven't even thought of yet? That's what you'll be figuring out as you build the next generation of AI. Thanks so much for joining me today.